Okay, this is the first part of chapter 23. Sorry about that. I've been using my computer for something else. Chapter 23 deals with circuits, electrical circuits. And we've already introduced the terminology. I've shown you what a battery would look like, what a resistor, what a voltmeter and an ammeter would look like, and so on. So what we're going to do is talk about the basic circuit. And what's interesting is that a basic circuit comes down to a battery or a generator attached to something that it is pushing electricity through. That is your basic circuit. We have a voltage or a source to push electrons and something to push it through. And for right now, our voltage will be a battery. So as a quick review, if I had 12 volts here, and I had, let's say we had 24 ohms, and usually these are marked. This would be resistor 1. If I was to ask then what is the current flowing, the current here would be V equals IR, so I is equal to V over R. 12 volts divided by 24 ohms, and that would be 0.5 amps. And if we wanted to find the power, then we could do I squared R, or now we could do 12 volts times 0.5 amps, and we would come out with 6 watts and so on. If I put a voltmeter across here, it would read 12 volts. If I put an ammeter in line, it would read 0.5 amps. Okay, now what's going to happen is as we go along, our circuits will become more complicated. And the first thing we have to do is ask, well, what if there were more resistors? And so that's really the topic of the lesson here today. What happens if there's more resistors? Let's say that we had, in place of that, we had the same thing. Let's do 12 volts. But let's say that over here, instead of one resistor, we had 2 resistors. And I have to get my glasses to see my notes. My first resistor is 16 ohms. And my second resistor is 8 ohms. And if I was to ask what's going to happen as we go through here, well, the first thing you should kind of spot is that in a sense, this is no different than the last problem. That little section right there is actually, although they're 2 separate resistors, they might be 2 separate devices, parts, that still totals to 24 ohms. So you could probably reason out it's going to be exactly the same as the last one. But what we're going to be interested in is what happens across each resistor. But the way that we solve this problem is to work it out as a single one. And so we are going to take our 12 volts and we're going to say, let's think of this now as one resistor. And that one resistor would be 24 ohms. I'm going to call this R total. Now, how did I get that R total? Well, here's where some of the teaching comes in. These resistors, we say, are in series. Series means one after the other after the other. They are one, you have to go through one resistor, then through the next one, then through the next one after that. And there's a real simple equation for the total resistance of several resistors in series. And that is we simply add them together. And that will give me my total resistance. So the very first thing you're going to do in the assignment is find the total resistance of some resistors that are in series. And if you can add, you can do this. So if I do on this one, I basically have 16 ohms and then 8 ohms. And if I add those two together, that's effectively the same as a 24 ohm resistor. Now, what we end up doing on a problem like this is working it through and working it backwards. First thing I would do is what we just did. I would find out what is the total current. And the total current here would be 24 ohms divided, 12 volts divided by 24 ohms, 0.5 amps. In other words, if we think of this like a river and water, electricity is like the current flowing, it's as if we have 0.5 amps flowing through the entire thing, which means that over here, each one of these resistors has to have 0.5 amps flowing through it. 0.5 amps, 0.5 amps. And because of that, we can find out what the voltage drop is across each resistor. In other words, I can think back now and I can say, what if I put a voltmeter across here? Well, the voltmeter is going to tell me how far the voltage dropped, and what would that be? For R1, V is equal to IR. There's 0.5 amps times 16 volts. This has 8 volts dropping across it. And here, the same thing. If I move my voltmeter, or actually I could leave it there and probe across here. If I went across here and asked what it would be, this would be also V equals IR, and that would be 0.5 amps times 8 volts. And that would end up being 4 volts. And you can now see what's going to happen. As this current flows, it's losing voltage. It loses 8 volts. We're down to 4 volts, then drops back down to 0. You can then figure out what the voltage drop and the current is across every single resistor. So let me do a second problem. And by the way, your book uses a little different notation. They don't say R total, they say R, and then they add up RA plus RB plus, but I use R total and R1, 2, and 3. I just like that better. So let me give you a different problem. Let's say that we had this one, that we have, well, let's do something different besides 12 volts. Let's say we have 30 volts here. And we come over here and we have a 2 ohm resistor. I'll put that in a second. And a 4 ohm resistor. We'll put our numbers in here in a second. I want this to work out nicely. Let's say we had a 5 ohm resistor, a 10 ohm, no, let's do a 10 ohm, a 20 ohm, and a 30 ohm resistor. So this is R1, R2, and R3. And what you're going to be asked is, what is the total current? What's the total resistance? Let's do that over here. What's the total resistance? What's the total current? And what is the voltage drop across each resistor? And if you think about voltage like elevation, like we've talked about, every time it's like water's running down a hill, each one of these is like a rapids. After you get done with that rapids, there's been some elevation drop, and that's the same thing as a voltage drop. So let's do our total first. The R total on this will be R1 plus R2 plus R3, and 10 plus 20 plus 30 is 60 ohms. So first thing we're going to do is rewrite this circuit as a single resistor, R total, 60 ohms, and this is 30 volts. You know, let's change this 30 to 15 just to make it different than the last one, okay? this means that, so we have the answer to this. Our total is 60 ohms. What's the current then? Well, current is going to be the total voltage, which is 15 volts, divided by 60 ohms, which would be 0.25 amps. Sorry, my computer kicked off. That's why my face came real close to it there. I just want to make sure it was still filming. And then that means that the total current is 0.25 amps. And now we can come over here. What is the voltage drop across each resistor? I wish I would have left a little more room. In fact, I'm going to erase this. And basically what we're going to do is find the voltage drop across I1, 0.25 amps times 10 ohms. And that'll be 2.5 volts. And V2 would be 0.25 amps times 20 ohms. And that will be 5 volts. And V3 is 0.25 amps times 30 ohms. And that will be 7.5 volts. Now, here's a check. Add those up. Does it come out to 15 volts? And yes, it does, 12.515. So that is called series resistors. Now, there's another type of resistance called parallel. And we will look at that next time in the next video. But let me give you what you should do on here. You should read through in chapter 23, page 617 through 621, 622. So 617, actually through 623, and then try problems 1 through 13 on. All right, so that's section 23.1, part 1. And we'll do the other video, and then we'll put all of these circuits together. We'll do that in our video on our class time on Tuesday.